The last videos showed the amazing abilities of other species to perceive and derive information, learn from experience, and adapt to their environment. This part will look at how other species utilize thought and reason to make decisions and plans. Descartes' idea that animals are programmed automatons is at odds with what we know about nature. Because nature is unpredictable and environmental conditions are always changing, animals have to make decisions and plans based on changing conditions and the knowledge they have acquired about the world. They have to think. How could they not think and manage to survive in the world? We now know the incredible ability of other species to navigate their way around the world requires complex thinking, decision-making, planning, and the cultural transmission of knowledge from their ancestors. While migration was once thought to be innate to a species, we now know it's far more complex. Because migration involves many choices about whether, where, and when to migrate. And these decisions take many factors into account. Animals change migration routes, destinations, and stopovers, depending on conditions. And migration plans are adapted or canceled, depending on the circumstances, which demonstrates the amount of thinking required for these journeys. As animals move through their habitat, they are confronted with repeated choices about how to react to environmental stimuli. There are many variables that can affect the availability of food, including weather, and the number of animals sharing the same territory. For this reason, some species use irregular migration patterns that constantly shift and adapt to new conditions. Studies have revealed why some deer are motivated to migrate into new territories each year, while others choose to stay put. Whether they choose to migrate depends on the conditions of their habitat, and they will only migrate if the circumstances call for it. The choice to migrate depends on trade-offs between its costs and benefits. Many animals choose not to migrate at all unless they are forced to by food shortages or severe weather. Within species, some individuals will choose to leave while others choose to stay. Members of the same species make different decisions based on the conditions of their area. Wood pigeons living in the temperate regions of Europe do not migrate, while the same species living in the colder north migrate to the warmer regions of the Mediterranean for the winter. While most egrets move south for the cold months, individuals from the southern U.S. may choose not to migrate at all. Western populations of cormorants will migrate to the Pacific coast, while groups living on the northern Atlantic coast will migrate to the southern U.S. And coastal Mexican populations choose not to migrate at all. So it's clear that migration is not just genetically programmed into a species, and that animals choose whether and where to migrate based on changing conditions and knowledge of their environment. We now know this knowledge is passed down from ancestors to new generations. Research from 100 scientific publications shows animals rely on social factors to guide migration. And social influences during migration are likely more widespread than previously recognized. Studies have shown that animals need the knowledge of their ancestors to learn migration routes. Researchers found that after extinct populations of bighorn sheep and moose were reintroduced to North America, they did not migrate as historical herds had. However, after several decades, newly established herds learned how to migrate by tracking the pattern of vegetation in the environment. Thus, newly introduced animals learned about their surroundings and shared their knowledge via social exchange, proving that environmental factors can be learned and that knowledge gathered through time is culturally transmitted to new generations. Animals act on knowledge and in response to the dynamics of their environment. They will adapt journeys and destinations depending on the weather conditions. When wildebeest travel in search of water sources, they will change their migration route if they see rain clouds or hear thunder. Pelicans will flock to wherever conditions are favorable and gather temporarily at lakes whenever they are flooding. These birds will fly from all over Australia to a lake that floods only once every 30 years. And researchers still don't know how they do this. Animals plan their migrations depending on environmental and weather conditions. And the complexity of their thinking is seen in the way they adapt these journeys, changing not just destinations, but also stopover sites, which are essential for refueling on long journeys. Goose migration stopover sites and wintering grounds have shifted because of changes in farming practices, availability of lawns and golf courses, and other changes in land use. Migratory geese are now adjusting when and where they migrate as a consequence of global climate change. Some groups of geese have become more sedentary and stop migrating at all. As environments change, so does the decision to migrate. And living close to human populations can eliminate the need for migration. Researchers found that changes humans have made to the environment appear to be causing birds to rethink their migration patterns. And while storks from Russia were still following their traditional routes, storks in Uzbekistan, surviving off human farms in the area, had completely ceased to migrate. They also found that if birds find a way to shorten their migration route, they will take it. Birds can learn new and faster ways to migrate from their elders and more experienced birds who have found more efficient ways to travel. Researchers discovered that homing pigeons have learned how to follow freeways and identify which exits take them directly home, and that their knowledge is continuously being expanded and passed on to the next generations. It's not just an incredible amount of geographical knowledge needed to adapt journeys, but also the ability to plan the timing of long journeys in advance, making sure that enough food will be available at stopover sites at the time of landing. The timing of migrations is affected by multiple factors, such as weather, body condition, and food and water availability at stopovers. Mismatched timing can coincide with depleted food sources at stopover sites. If stopover conditions are unfavorable, birds will depart for other known stopovers. They determine the duration of their stopover based on the circumstances, such as food availability, their energy reserves, and the time and energy they need to reach their final destination. They base their departure decision not only on fueling rates, but also on actual fuel stores. And they appear to factor future stopovers into this decision. Because birds with many stopover sites available further on the migration route were not influenced by their actual fuel stores for the decision of when to depart. Other factors also influence departure decision, such as weather factors and predation risk. The factors may interact and may change with time pressure. They account for both time and energy when traveling, by balancing their energy reserves with the speed they can travel, and with the optimization of energy use by forming positions to reduce wind resistance, utilizing wind and ocean currents, and sometimes hitching rides on merchant ships. The ability to adapt the timing of these multi-thousand-mile journeys shows animals' ability to think about time and plan ahead. And it appears they can even adjust the time that their journey takes based on the time they plan to arrive and the time they depart. Researchers have found that as conditions change due to climate change, some birds are compensating by delaying the start of their journey for up to 10 days and completing the journey up to 43% faster by moving more quickly and making fewer or shorter stopovers to refuel along the way. The ability to adapt the timing of journeys is also seen in reindeer and caribou migrations. Researchers found that they use tactical decisions that balance energetic reserves and forage availability. We also found that the speed of migration was highly plastic, with later migration departure times followed by shorter migration durations. This plasticity made arrival timing independent of departure timing. So these groups can change the speed and duration of their journey, depending on the time they intend to arrive. These journeys require the ability to foresee conditions at a certain point in time, based on knowledge gained from the past. Zebras appear to migrate to the location where foraging conditions were best in the past. They seem to navigate to their destination based on memory and, importantly, forecast conditions several months after arrival. It is now established that animals utilize thought and reason to make decisions and plan ahead. Although these were once thought to be human traits, there are now countless examples demonstrating that other animals from across the species can plan ahead. That they can judge and measure time, and that they use logic and reason. Researchers have recently proved that giraffes use statistical reasoning and chickens use deductive reasoning. That humans are not the only animals capable of slow and thoughtful deliberation. and that animals cannot just act. They can act intelligently, rationally, intentionally, and for reasons.